Hello. So we are solving the exercise of chapter 7, Continuity and Differentiability of Functions from ISC Mathematics grade 12 by OP Malhotra and SK Gupta. The first question is, examine the continuity of the function f of x equals 2x square minus 1 at the point x equals 3. Now, in order to find the solution of the question, you should first know what a function continuous at a particular point means. A function f of x is continuous at a point x equals a if it satisfies the following three conditions. The first condition is the value of the function at the given point a should be defined. Defined means it should have a value, a valid value, not infinity or minus infinity. The limit of the function as x tends to a, it should exist. And the last one, the value of this limit as x tends to a for the given function should be equal to the value of the function at the given point a. We will be satisfying these three properties in order to show that our given function is continuous at the point x equals 3. So here the function f of x is given to be 2x square minus 1 and the point a is 3. So we will satisfy the first condition. We will find the value of f at 3. It becomes 2 times 3 square minus 1, that is 18 minus 1, which is equal to 17. Now this is a defined value. The b point, we will find the limit of the function as x is tending to 3 and my function is 2x square minus 1. If I put in the limit value, I will plug in x as equal to 3 and I again get a defined number, so the limit exists. For the part 3, now I need to show that limit x tending to 3 for the function 2x square minus 1 is equal to the value of the function at the point x equals 3. Clearly, from the part A and B, this is true. We can see that from the parts A and B, the value of the limit as x tends to 3 for the function is equal to the value of the function, that is equal to 17. So from A and B, C becomes true. Thus, we can conclude that the function f of x equals 2x square minus 1. It is continuous at the point x equals 3. Let's move to question 2. The question 2 is asking, examine the following functions for continuity. जब भी हमें functions की continuity को examine करना होता है, तो we have to see the problematic points. Problem कहाँ पे आ सकती है? Mainly problem तभी आती है, या तो हमारा कोई split function हो, या फिर function के denominator में कोई ऐसी चीज़ हो जिससे denominator 0 हो जाए और function की value at that point undefined हो जाए. तो हम वही चीज़ आइडेंटिफाई करने की ट्राई करेंगे. अब हमारा फर्स्ट फंक्शन है f of x equals x minus 5. What is this telling? ये जो x minus 5 है, इसमें कोई प्रॉब्लम वाला पॉइंट तो नहीं दिख रहा. मैं इसमें x की कोई भी वैल्यूज डालूं, मुझे हर x की वैल्यू के लिए कोई ना कोई फंक्शन की का वैल्यू मिलेगा ही. Because this thing is happening, there is no problematic point, so the function is continuous for all the values of x. अब हम b पार्ट की बात करते हैं. The b part says the function is 1 over x minus 5 where x is not equal to 5. सबसे पहली चीज, try to find the problematic points. इसमें problematic points कौन से हैं? Problem हमें तब आएगी जब denominator 0 हो जाए. So the problematic point here is x equals 5, x की वैल्यू 5 नहीं होनी चाहिए, लेकिन क्वेश्चन में एक चीज और मेंशन्ड है, क्वेश्चन में मेंशन्ड है कि x is not equal to 5. It means x is equal to 5 वाली वैल्यू को उन्होंने डोमेन से ही हटा दिया. So because the problematic point is not in the domain, the function is again continuous for all the values of x. This is the symbol for all x. So I'll be using it from now. C part is f of x equals x square minus 25 over x plus 5 where x is not equal to 5. Again, अगर इस फंक्शन में हमें x not equal to -5 अगर not equal to -5 नहीं दे रखा होता तो वही हमारा प्रॉब्लमैटिक पॉइंट होता एंड दैट वुड हैव बीन द पॉइंट ऑफ डिसकंटिन्यूटी. लेकिन इस फंक्शन में प्रॉब्लम कहाँ पे आएगी? x इक्वल्स -5 पे आएगी. -5 वाला पॉइंट इन्होंने डोमेन से निकाल रखा है. सो द फंक्शन f of x is continuous again for all x. The D part of the question is f of x equals modulus x minus 5. अब modulus के बारे में जो लोग नहीं जानते, it gives only positive values for the given function. अगर आप इस modulus function को draw करने की try करेंगे, y axis, the x axis, and because -5 है, modulus function की जो peak है वो right पे shift हो जाएगी and my function will look like a V-shaped graph only, जैसे normal modulus function दिखता है but shifted towards the right. You can see कि ये कहीं पे भी break नहीं हो रहा. There is no breaking point, there is no gap in between in the given graph, so it is also continuous. Now we are starting question 3 of the exercise. It says a function is defined like a split function जिसमें value is x square minus 4x plus 3 over x square minus 1 if the value of x is not equal to 1 and the value of the function is 2 if the value of x is equal to 1. We have to check the continuity of the function at x equals 1. So हमने question number 1 में already revise कर लिया है that हमें 3 conditions satisfy करनी पड़ती है in order to show that a function is continuous. What was the first condition? The first condition was f of a is defined. So here we have to see if the value of f of 1 is defined. Here f of 1, now I know from the split function कि जब x की वैल्यू 1 है तो फंक्शन की वैल्यू 2 है. So f of 1 की वैल्यू हो गई 2 which is defined. So no problem here. The second condition that we need to satisfy is the limit when x is tending to a for the given function should exist. Now let's see if the limit exists or not. Here limit x is tending to 1 and the function. Now the thing is, what function should I take? Should I take the first one or the second one? Now see, x tending to 1 means it is not actually reaching 1, it is either a little before 1 or after 1. 1 के थोड़ा सा आगे है या 1 के थोड़ा सा पीछे है. तो हम actual 1 वाली वैल्यू नहीं लेंगे, हम फंक्शन लेंगे दूसरा वाला जहाँ पर वैल्यू ऑफ x is not equal to 1 because tending to defines कि x की वैल्यू 1 के बहुत पास है लेकिन वो exactly 1 नहीं है. Now if you put in the value 1 inside it तो ये not defined आएगा because denominator में you will get a 0. Okay, but we can improve this situation. Limits find करते हुए हमने ये सीखा है कि we can factorize the function and simplify it ताकि limit exist हो जाए. So what I do, I factorize the numerator. It becomes middle term splitting से x square minus 3x minus x plus 3 over x plus 1 and x minus 1 by using the property a square minus b square. Now limit x tending to 1. If I factorize the numerator, it will become x minus 3, x minus 1 over x plus 1 and x minus 1. Now you can clearly see that the x minus 1 and x minus 1 gets cancelled. तो जो problem वाली बात थी वो finish हो गई है. Limit x is tending to 1, x minus 3 over x plus 1 is what we are left with. Now I can directly plug in the values. X की value 1 put करी, it becomes 1 minus 3 over 1 plus 1, which becomes minus 2 over 2, which is minus 1. So limit is well defined. Now the third condition that we have to satisfy for a function to be continuous, that situation was कि limit x is tending to a, f of x की जो value आनी चाहिए, it should be equal to the value of the function at that point. So here we are getting limit x tending to 1, f of x as equal to -1, and the value of the function at 1 we just found out it is equal to 2. Now because both the values are not the same, the given function f of x is not continuous because the third property is not satisfied.